Good morning students, welcome to the today's session. In this session we will see worksheet problems, particularly worksheet 3 problems in algebra chapter. Okay, so worksheet 3 we are going to discuss now. See, the first question is based on the degree of the polynomial. So first of all we have to know what is meant by degree. A degree of a polynomial is sum of the powers of the variables. Here we have two cases. If the given polynomial has only one term and if the given polynomial has more than one term. If we have only one term, nothing but monomial, in that case the sum of the powers of variables will become the degree of that monomial. While coming to the polynomial, like an algebraic expression is given, then we have to find out the degree of each and every term. Among them, the highest degree of the terms will become the degree of that polynomial. Okay, now based on this concept, let us discuss all the 9 problems in question number 1. First one is 1 plus x square. In this, first term is 1. 1 is a constant. If there is no variable in a term, then we will call that term as a constant term, isn't it? So for the constant terms, the degree will become 0. Understood? So if there is no variable, then automatically the degree of that term will become 0. So the first term degree is 0. Next, coming to the second term, here we have x. Its power is not mentioned there. If there is no power mentioned, then there will be 1 by default. So the degree of the second term is 1. Next, degree of the third term is 2. Only one variable is there here. Its power is 2, so that its degree will become 2. Therefore, the highest degree of all these 3 terms is 2. That's why the degree of the first question is 2. Coming to the second question, x minus 6. X is a variable. Its power is not mentioned, so that its power will become 1 by default. That's why the degree of the first term will become 1, and second term is a constant, so that its degree will become 0. So 1 and 0, in these two, 1 is greater. That's why the degree of x minus 6 is 1. Okay, now coming to the third question, 6 minus 5x plus 2x square. 6 is a constant, so its degree will become 0. 5x is a term in which x is a variable. Its power will be 1 here, that's why its degree is 1. And coming to the third term, the power of x is 2, so the degree of this term is 2. So in these 3 terms, the degree of these 3 terms, if you observe, 0, 1 and 2 will be there. That's why the degree of this expression will become 2. In a same manner, coming to the fourth question, 4 plus y square. 4 is a constant, that's why its degree will be 0. Next, y square, here y power is 2, so that degree will become 2. So finally the degree of 4 plus y square will be 2. Now fifth one, y minus y cube. Y power 1 by default, that's why its degree will be 1. And the second term is y cube, its degree is 3. So 1 and 3. In those two, 3 is the greatest number. That's why degree of y minus y cube will be 3. Now coming to the sixth question. M minus m square plus 3m power 5. First term degree is 1, second term degree is 2, and third term degree is 5. The highest degree is 5 here. That's why degree of m minus m square plus 3m power 5 is 5. Next, 3 plus 2p plus p square minus 6p power 4. All the terms degree we have to find out. So first term degree 0, second term degree 1, third term degree 2, and fourth term degree 4. So the highest degree is 4 here. That's why degree of the seventh polynomial is 4. And eighth polynomial has only two terms, z cube and 8. Z cube degree is 3 and 8 degree is 0, so that the degree of this polynomial will be 3. And coming to the ninth question, 1 minus 2t plus t square minus 3t cube plus t power 4. The degree of all the terms, if you find, they will come like first term degree 0, second term degree 1, third term degree 2, fourth term degree 3, and fifth term degree is 4. So 4 is the greatest degree here. That's why the degree of this polynomial will be 4. Okay. So now based on the degree of a polynomial, we have one more question to discuss. Let us see now. Yeah, here it is. This is the second question. Here also he is asking find the degree of each of the polynomials. The first one is x plus 2y minus 3z. The first term degree 1, second term degree 1, and third term degree is also 1. That's why this polynomial degree is 1. Next, coming to the second question. In each and every term we can see two variables. In the first term we have xy, means x power 1, y power 1. To find the degree of xy, we should add the powers of variables. So here x and y are the variables. That's why their powers, if you add 1 plus 1, it becomes 2. In the same manner, yz is the second term. Their powers will be 1 and 1. If they are added, we will get 2 again. In the same manner, for the third term also, the degree will be 2. So first term degree is 2, second term degree is 2, and third term degree is also 2. That's why the degree of the second polynomial becomes 2. Next, coming to the third question, x square minus xyz. First term degree is 2 here. Second term contains 3 variables x, y, and z. Their powers are 1, 1, and 1. So that to find the degree, we have to add the powers. So 1 plus 1 plus 1 gives 3. That's why second term degree will become 3. First term degree is 2 and second term degree is 3. The highest degree is 3. That's why the degree of third polynomial becomes 3. Fourth question, m square n. First term m square n means m power 2, n power 1. So 2 and 1 if you add, then we'll get 3. Next, second term m power 1 and n power 2. The two powers, if you add 1 plus 2, if you add, then we will get 3 again. And coming to the third term 5mn, in that m power 1 and n power 1, if those powers are added, then we'll get the degree of the third term, that will be 2. Next and last term is 6, so the degree will be 0. Among these all degrees, 3 is the greatest number, that's why degree of this polynomial becomes 3. Now coming to the fifth question, p square q square is the first term. So powers, if you add 2 plus 2, we will get 4. And coming to the second term, p q power 2, p q square, we will call the power 2 as a square. So p power 1 and q power 2 are present. So 1 and 2 if we add, we will get 3, so that the degree of second term is 3. In the same manner, degree of the third term is 3 again, and the fourth term is a constant, that's why its degree will become 0. So among all these degrees, the highest value is 4, that's why degree of the fifth polynomial is 4. Coming to the sixth question, their first term is m power 2 and n power 3. If the powers 2 and 3 are added, then we will get 5. So the degree of the first term is 5. Next, degree of the second term we want, m power 1, n power 2. 1 and 2 if we add, we will get 3. So the second term degree is 3. And the third term has only one variable n, its power will become the degree of that term. So its power is 4. First term degree is 5, second term degree is 3, and third term degree is 4. Among them, the highest degree is 5. That's why the degree of the last sixth polynomial becomes 5. Okay. Now let us go to the third question. Here it is. He is asking simply which of the following algebraic expressions are not polynomials. Which of them are not polynomials? So first of all, we have to know what is meant by a polynomial. A polynomial is a special type of algebraic expression. A polynomial is a special type of algebraic expression in which powers of the variables should be whole numbers. You know the whole numbers. They are 0, 1, 2, 3, 4, 5 and so on. So in place, if the powers of variables are 0, 1, 2, 3, 4 and so on, then only we can call such algebraic expressions as polynomials. So here we have to discuss which are not polynomials also. In the exemptional, if we know the polynomials, we have to differentiate which are not polynomials, right? So for that, the first one is, if the variable comes in the denominator, then indirectly it indicates the power is negative. Negative means minus 1, minus 2, minus 3 and so on, like that. Okay. In the same manner, if the powers of variables are negative numbers, in those cases the algebraic expressions should not be called as polynomials. They are just algebraic expressions. They don't become polynomials, right? So here the main condition, powers of the variables should be whole numbers. If the powers are negative numbers, or if the variables come in the denominator part, in those cases we will say the powers of variables will become negative. That's why they are not polynomials. In a same manner, if the powers of variables will be fractions, then also it is not a polynomial, right? Because the fractions are not at all possible in the whole numbers set. we can see only 0, 1, 2, 3, 4, 5 and so on. That's it. We cannot see 2 by 3 or 5 by 6. Such fractions we can't see, and they are not there, of course, in the whole number set. Okay, so now based on this information, let us see the key for third question, all problems. In the first problem, 3 by 5 x square, so their variable is x, its power is 2, which is a whole number. Next, second term is 5 by 4 x, their variable is x and its power is 1. Next, 2 by 3 is a fraction which is a constant, right? So that its degree will become 0. Now if you observe all the powers of variables, they are just whole numbers. That's why this expression is a polynomial. And coming to the second question, here 1 by 4 x cube minus 2x square plus 7 is given. Here x power 3 and x power 2, they are whole numbers. That's why it is also polynomial. And coming to the third question, x power 3 minus x power 2 plus x minus 1 by x plus 5. Here first term, second term, third term, those three terms where powers are whole numbers, but while coming to the fourth term, the variable comes under the denominator. That's why it is not a polynomial, because if the variables come under the in the denominator part, then indirectly it indicates their powers are negative. That's why such algebraic expressions are not polynomials. In a same manner, fourth question also contains a variable in the denominator. That's why it is not a polynomial. And fifth question, in that also we have the second term containing the denominator as variable, so that it is not a polynomial. And sixth question, there also the variable is present in the denominator part. X square you can see in the denominator part, which is in the third term. That's why sixth expression is also not a polynomial. And seventh question, in that second term contains a variable in the denominator, so that it is not a polynomial. Coming to the eighth one, there also second term contains the denominator x cube, which is a variable. That's why it is also not a polynomial. Understood? So if the variables come in the denominator part, they are not polynomials. Based on that condition, we can differentiate which are polynomials, which are not polynomials, particularly in this question. Understood? So now let us see question number 4. Yes, so here also he is asking again, which of the following algebraic expressions are not polynomials. Okay, so the main condition, the powers of variables should not be negative numbers, and variables should not come in the denominator part, and also powers of variables should not be fractions. In those cases, the algebraic expressions cannot be called as polynomials, right? So now let us see first question, m square plus n square minus 2mn. So here m power 2, n power 2, and the third term has mn whose powers are 1 and 1. These all are whole numbers, that's why it is a polynomial. And the second question contains x cube, y cube, z cube, x 3xyz. So every term contains the powers of variables as the whole numbers. That's why the second expression is also a polynomial. Coming to the third one, a square b, ab square, and ab. These all are the variables and their powers are whole numbers. That's why it is also polynomial. But coming to the fourth one, in the third term, like see 2 by y is there. y square plus z square minus 2 by y plus 3z. That's the expression. In this expression, third term is 2 by y. So the y is in the denominator part, which is the variable. That's why this expression is not a polynomial. In a same manner, fifth question also contains a variable n in the denominator part, which is present in the third term. That's why it is also not a polynomial. And the last expression, x square y square z square xy yz zx. In all these terms, the powers of variables are whole numbers. That's why this algebraic expression is also a polynomial. Okay, so as of now we have seen which are polynomials, which are not polynomials, isn't it? Now let us see the next question. Question number 5. State true or false. Which are true, which are false. So the first one, let us see. X plus 1 by x plus 3 is a polynomial of degree 1. So first of all, this is an algebraic expression in which a variable x is present in the denominator in the second term particularly. So if the variable comes in the denominator, so that expression will not be a polynomial. So that's why it is not a polynomial, and we don't want the degree of this. That's why the given statement is a false statement. Right? Now the second one, 2 by 3 is a constant plus 3 by 5 x square. Here x power is a whole number plus x cube. Here also x power is a whole number. So these whole numbers are present in as the powers of variables. That's why this expression is a polynomial actually. But in this sentence, what is given? It is not a polynomial is given. That's why this is a false statement. Coming to the third one, 2 minus z cube. 2 is a constant, z cube, there 3 is a whole number. So this expression is a polynomial, and in the sentence also it is given the given a 2 minus z cube is a polynomial. So it is a true statement. And coming to the fourth question, xy minus x by y plus 5 is a polynomial of degree 2. So first of all, we have to check whether it is a polynomial or not. Then after we can say its degree, right? So now here xy minus x by y plus 5 is given. There y comes in the denominator part in the second term. That's why this algebraic expression is not a polynomial, but in this sentence it is given it is a polynomial. That's why this is a false statement. And coming to the fifth statement, m n power 2 minus m power 2n plus 2mn plus 6m minus 3n is a polynomial. Yes, it is a polynomial. If you observe carefully, the powers of m and n are only whole numbers. That's why this is a polynomial in m and n of degree 3 he is saying. Let us find the degree. So first term is m power 1 n power 2. So 1 plus 2 is 3. So first term degree is 3. Second term m power 2 n power 1, so that its degree is also 3. And third term m power 1 n power 1, the degree becomes 2. Fourth term m power 1, degree is 1. And fifth term n power 1, its degree is also 1. So 3 3 2 1 1 are the degrees of the terms of given algebraic expression. So among them the highest degree is 3. That's why the degree of this polynomial is also 3. So the given statement is true statement. Okay, so with this 5 problems key we have discussed in this session, and this video will be placed in the announcements button. Again, if you want to see and if you want to check your answers, you can verify. It will be available till 6 p.m. today, right? Thank you for this session. Have a nice day.